So for this task, we'll be using this heating graph of a substance that you should see on the page as well, and I will go through it and we'll look at a few of the different points and what phases the atoms will be in. So in the first temperature increase, this substance will be a solid until we hit around 55 degrees Celsius, which will be the melting point. And then we'll have this plateau where the substance will be melting, and then we'll hit the point where it's all melted and it'll be liquid, which is going to be heating up until around 90 degrees, and that'll begin boiling. So that's the boiling point. And then as it's boiling, it'll be releasing vapor, and at some point after that last plateau, that substance will be entirely water vapor, and that will increase in temperature as well. So the condensation point will be actually the same as the boiling point. If you were to read this basically backwards as a cooling curve, condensation point will be 90 degrees Celsius when the vapor starts turning back into liquid. And similarly, the freezing point will also be the same temperature as the melting point when that liquid begins to start turning into a solid. And so that will be at 55 degrees. And at 70 degrees Celsius, you can see that is within that second increase in temperature, and that substance will all be a liquid at that point. As it's reaching its boiling point, it won't be solid or vapor yet, so it'll all be liquid. At 90 degrees Celsius, the substance could be a liquid or a vapor. It's still boiling and releasing that vapor, and after 90 degrees Celsius, any higher than that, the substance will only be a gas. So for this next question, we're going to be using Boyle's law. So that relates to pressure and volume. So that states that P1 times V1, meaning the original pressure and the original volume, will equal to P2 times V2 after we change one of these variables. So in our question, we have most of the variables. So we know that P1 is 1.12 atmosphere, and P2 is 1.5, so we've increased it. And we also know that V1 is 2.50 liters, so we're trying to find out what V2 is. And to do this, we're going to want to change this equation and get V2 alone. So we're going to divide this side of the equation by P2. And when we plug that all into the calculator, we'll have 1.12 times 2.5 divided by 1.5 equals 1.87 liters. So that's the new volume that the gas will have when we increase it. For this next one, we're going to be using Avogadro's law, which states that volume and moles are directly proportional with constant pressure and temperature. So it can be written as N1 divided by V1, which is the amount of gas and the volume of gas, equals N2 divided by V2. So we have V1, which is 1.25 liters. We have N1, which is 0.85 moles of the gas, and we have N2, which is 1.4 moles, so we're looking for V2. So we can plug these into this equation, and we have 0.85 divided by 1.25 should equal 1.4 divided by V2. So this gives us 0.68. So we can divide 1.4 by 0.68, and it should be 2.05 liters would be V2. So that's how many liters we would have with 1.4 moles of gas.